Zachary Geishert, and I will be doing the wavelength problem. Background. There are two types of waves, longitudinal and transverse waves. Longitudinal waves are waves that travel in the same direction that the medium vibrates. Transverse waves are waves that travel at right angles to the medium. Background continued. An example of a longitudinal wave is sound waves, concussion waves, and earthquake waves. Examples of transverse waves are all EM waves, which are light and radio waves, and ocean waves. All EM waves travel at the speed of light, which is 3 times 10 to the 8th meters per second. Remember that because we'll need it later. Variables. Frequency, the number of waves that pass a point per unit time. The symbol for frequency is F, and the unit is Hertz. Wavelength, the distance from a point on a wave to the same point on the next wave. The symbol for wavelength is lambda, and the unit is meters. Wave speed, the speed of a wave. The symbol for wave speed is V, and the unit is meters per second. Formulas. The first formula is wavelength equals wave speed over frequency. The second one is frequency equals wave speed over wavelength. And the last one is wave speed equals wavelength times frequency. And there's your triangle. Problem. A radio station is broadcasting at a wavelength that has a frequency of 88.1 megahertz. What is the wavelength? So, as you can see here, we have our radio station, and its wave speed is 3 times 10 to the 8th meters per second. Its wavelength is unknown, and the frequency is 88.1 megahertz. Givens. So, frequency is 88.1 megahertz. Wave speed is 3 times 10 to the 8th meters per second, and wavelength is unknown. Equation. The equation we will be using is the easiest since we are trying to find wavelength, and its wavelength equals wave speed over frequency. Plug in. So right here we're using our givens and plugging into that equation, so we get wavelength equals 3 times 10 to the 8th over 88.1 times 10 to the 6th. And you may be wondering where that 10 to the 6th came from. That's just because mega in megahertz is denoted as a 10 to the 6th. And they are equal and interchangeable. So, as you can see, there's our equation again. And you can break it up to make it easier, which is what I did. So I broke it up into 3 divided by 88.1 times 10 to the 8th over 10 to the 6th. And you get 3 divided by 88.1 equals 0.034 times 10 to the 8th over 10 to the 6th. And that equals 0.034 times 10 squared, which is 100. So all you have to do is move the decimal place over twice because you're multiplying. And that gives you wavelength equals 3.4 meters. Answer. So if a radio station is broadcasting at a wavelength with a frequency of 88.1 megahertz, that wavelength would be 3.4 meters. Thank you.